Welcome to Walkabout the Galaxy, the downsy-dervy astronomy podcast where the science is universal, the opinions are personal, and the intelligence is natural.
Facts.
The last time it was topsy-turvy.
Oh, that's cute.
This time it's downsy-dervy.
Great.
We are strange, charm, top, and down. The Astroquarks, also known as Josh Caldwell.
Addie Dove.
Jim Cooney.
And Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida with 3 real quarks and 1 virtual quark. Be sure to follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram, where the facts aren't checked, but you can always trust the Astroquarks.
Yep.
Catch our videos on YouTube. We are at Walkabout the Galaxy. You can email us at wtg@ucf.edu. There is still a limited supply of Walkabout the Galaxy t-shirts. If you're interested in supporting the show,
It's a great Valentine's Day
send
gift.
an email
Yes.
to wtg@ucf.edu.
Yes.
Our stumper today is science fiction travel related.
Okay.
Suppose you're going to permanently relocate to another planet. Now, I think we've previously had a stumper where you get to pick your science fiction planet destination because I'm pretty sure Jim wanted to go to Risa. Am I imagining that, Jim?
No, that's
Yeah,
facts.
no.
Was that just
that's
a
right.
conversation we were having?
So this time it's how you get there. Okay?
Oh.
It's a one-way trip. Aliens have arrived and upended your world. Maybe it's like Hitchhiker's Guide to the Galaxy. They're clearing out the Earth to make way for an interstellar highway.
Mm-hmm.
Everybody's getting relocated. You're getting relocated. Your friends and family are going on a one-way trip. And oddly, they offer you 2 modes of locomotion. You don't know any information about how safe or tried or tested or true either of them is.
Oh.
One is like a Star Trek transporter. And the other is suspended animation, like, cryo freeze type thing. So which of those things, and all your peeps are going with you the same way, right? So you don't need to worry about the fact that one takes longer than the other, okay?
Mm-hmm.
Which one of those do you want to subject yourself to?
Wait.
Welcome to Walkabout the Galaxy.
Wait, no, I think I thought it was... wait, what are the 2 options?
Transporter
Uh-huh.
or like suspended animation.
Oh, okay. For some reason, I thought there were going to be more options than you asked. And I
No,
was
it's just like Star Trek version or like Aliens
I feel like we've done
version.
this before also.
I'm going cryo freeze every time.
Yeah? You don't want to
Really?
be a clone of yourself?
I have some philosophical problems with that. I don't.
With the whole transporter. But you're
Is it
forgetting
you
about
that comes out the other end or whatever. I don't. Even if I'm not worried about the safety of it, I'm freaked out by it, so I'm going cryo.
even though it's got Heisenberg compensators?
Even with the Heisenberg compensator.
Even with the Heisenberg compensators.
I trust the Heisenberg compensators, but it's not me, is it? Is it? I don't know. Anyway.
But does that matter?
Well, you tell me, Audrey.
I don't
Which one
think
are you
so.
choosing?
Yeah, I want the transporter.
You're taking the transporter.
I think it'll be quicker.
Just get it
not
over
that
with?
I'll know, but I don't know.
You would know.
I don't know. I mean, not that I would
You won't-
necessarily feel the time.
You won't be sore or achy.
Yeah, and
afterwards.
if something bad happens,
The first
I feel
versions, people got sick a lot when it happened before they perfected them.
With transporters? Yeah.
Oh, well, I don't know. I just feel like if it doesn't work, then I'll just disappear,
gone.
and that's better than waking up in a
Right.
in a vat of fluid and drowning in a bag or
Oh,
something.
okay. Yeah, so the failure mode is preferable.
Yeah, I think
Right.
so.
Okay. Addie, what about you?
I guess transporter.
Guess transporter. I'm like Jim, so I have a problem. Even though if we trust that it works perfectly and it's a perfect copy that comes out the other side, you're still getting disintegrated.
Sure.
Yeah.
But think how great it would be to be able to go to a meeting in Paris.
So
Because
somebody,
you could use it at a local transporter you
So-
can use on Earth in addition to interstellar travel.
yeah.
Mm-hmm.
Cryo
True.
doesn't help with that. But maybe if we have
But this is
cryogenic
just this
freezing
one
and
trip.
stuff, we also have better point-to-point on Earth.
This
so.
is just this one trip.
If it's just one trip, take me apart. It's fine.
Take you
Yeah.
apart, put you back
I
together
don't want to
again.
get frozen for
But
months
no,
and years.
Yeah.
No.
All right.
No.
Because also
No.
there's the time
No.
thing, right? Because
No.
what if then if you do those super long trip, everyone you know
They're
is
all
either
coming
coming
with you. They're coming with you.
or getting older.
They're
What
coming with you.
happens while you're out there? I don't know.
Yeah,
Yeah.
something can hit the spaceship or something.
That's true.
I mean, that's pretty
I just meant like
low.
what happens while you're
Maybe-
out for 5
maybe
to
there's
10
Yeah.
decades.
Maybe
Yeah.
there's an economic crash on Risa, and it's not as cool a place to get to
Yeah,
by the time you get
exactly.
there. Yeah.
Or there's like it
These-
turns into the villages. And you
Jim,
just
what
don't
would
wanna go
your
there.
would your response change at all if the transporter actually sent a matter stream of your stuff to the destination and reconstituted you from yourself?
I think so. I think
Interesting.
Really?
Yeah,
think that's
interesting. Even though every hydrogen atom is just like every other hydrogen atom.
even though, it's not
Jim's
even.
hydrogen atoms are so special.
But like
Yeah.
all the like
And even
you know,
though
you
it-
shed skin and then grow new skin and then like it
I know,
it's
I know.
not it doesn't
Your
matter.
DNA is changing
And
all the
it's
time
even-
because it's getting hit with cosmic rays.
Yeah.
And even, I mean, like hydrogen atoms, they don't have identities. I mean, like, or
Right.
Yeah.
electrons and stuff like that.
I
I know,
hydrogen
but
would
it's-
like to disagree with you right now.
I don't know.
Yeah, I get
don't
it.
know.
I get it.
We don't want to anthropomorphize hydrogen.
Not today.
Not today.
Well, it's 2-2 on that one. So you two will get there before me and Jim.
And
So-
then we'll
Yeah.
Be dead by the time you get there.
And then you'll be dead by the time we get there. Right.
Yeah.
Doesn't bode well for the podcast, everyone.
Well,
Bummer. Yeah.
Today we will talk about an ancient ring around the Earth, early supernovas, red dots, rocket launches, mishaps, and much more. But first, this episode of Walkabout the Galaxy is brought to you by the Hill Sphere. If you're
Is
looking
this
for
a political
hill,
ad?
no, no.
The hill
the
in
hill,
DC.
that hill. Yeah. The Hill Sphere. If you're looking for a hill shaped like a sphere, you'll have to go elsewhere. But if you want to make sure your belongings are safely within your gravitational grasp, get the Hill Sphere. While it's neither a hill nor a sphere, the Hill Sphere lets you know where your gravitational pull hold sways so that you can organize your orbiting materials without fear of them wandering off to orbit someone else. Find your zero-velocity surface with the Hill Sphere and hold on to what's important in life.
Aw.
The Hill Sphere, true to the game.
basketballs.
EA Sports.
Jim,
I like that. That's a good one, Eddie.
EA
Yeah, I'll go
Sports.
with Adidas. Yeah.
Adidas.
That too.
Okay, you're sort of in the right track, but you need to be thinking more about spheres.
Oh.
Basketballs.
Balding.
That was what I was about to say.
Nice.
Yeah.
I was like, who makes the basketballs?
Right.
Oh,
Audrey gets credit. She
I'll
said
take
Good job.
basketballs.
The
thank
basketball.
you. Thank
Yeah.
you. Thank you.
So a whole bunch of space news.
So much space news. So much launching, so much exploding.
Yeah.
Yeah.
Right.
So much news.
Some
Whoa.
exploding we got to see.
Yeah.
Some we got to see launches, landings, and explosions.
Yep.
Can we be
all
more
within
specific?
24 hours.
Controlled explosions and uncontrolled explosions. So first on the docket was the launch of a Falcon 9 vehicle. Sometime this week. I don't know. I haven't gotten a lot of sleep this week because there's been a lot
But
of
it
late night
happened.
launches.
Yeah.
Tuesday
Because-
night?
I don't know.
Some night.
Tuesday night, Wednesday morning.
Yeah, that was
11
it. Was just a
a.m.
Falcon 9, which is like meh when you're here these days.
Right.
But this one I was excited about because it
Because?
had 2 lunar landers on board:
Right.
a Firefly, Blue Ghost lander, and the iSpace Resilience. It's all capital, so you have to yell it.
Okay.
Lander. And so
Is
those.
it actually a horrible
I
acronym?
don't.
Is it one of
I
these horrible
haven't-
acronyms?
I haven't looked it up.
Yeah.
Their previous one was an all capital thing, also, and I don't know if it was an acronym.
Okay.
But
And
so
Blue-
those are
Blue Ghost has nothing to do with Blue
It
Origin.
has nothing
is that
to do with
right?
Blue Origin.
It's just there to confuse us.
asterisk. Anyway, no, it has nothing to do with Blue Origin. It's just confusing.
Okay.
Yeah, I don't know if it maybe uses similar fuel that like Blue Origin uses, which has a blue flame. But
Yeah.
anyway, nothing as far as I can tell to do with Blue Origin.
Okay.
So those vehicles both were launched into orbit, into an Earth orbit, and they successfully separated from the launch vehicle.
And they're heading to the moon.
And they're yes, except that Blue Ghost will orbit the Earth for like 20 days or something, and then do a transfer into a lunar orbit and then land. So it actually doesn't land on the surface for like 45 days. It has one of the longer transit times.
Is this going to southern polar region?
No.
This one is not.
it's going
Okay.
to Mare Crisium.
Mare Crisium.
Yeah.
Okay.
March 2nd, I think, is the
Something
That's
like that.
Latin
Yeah.
for sea Crisium.
The Crisium Sea.
in Crisis.
Sea of Crisis. I think that's right.
Yeah. I looked this up.
And then the Resilience lander is going somewhere on the
about this
moon that I will check in the next couple minutes.
Uh-huh.
It has an even longer transit, actually, I think.
Okay.
Oh.
But they're both on the way.
Okay. Cool. And
And
they're all,
everything-
they can take these nice, long, leisurely orbits out there,
Yeah, and they've done
staying-
checkouts.
staying within the Earth's hill sphere the whole time.
Yeah.
Oh.
NASA has 10 payloads on board Blue Ghost, like science and technology payloads, and they've been getting like checkouts, and things seem to be going well so far.
Is that mission in the same series as your LunarVise
It
mission?
is.
So it's a
Yes.
it's a Prism.
It's not a
slash
Prism,
Eclipse-
it's a CLIPS mission.
Eclipse
Yeah, so
mission.
this is the first one from Firefly. It's a CLIPS mission, so Commercial Lunar Payload Services mission. And so all the payloads are contracted from NASA. They're not like PI-led payloads in the same way that ours is. But there are some from industry and from NASA, or NASA collaborating with industry, and some from internal to NASA. Yeah.
Okay, cool. And
then-
Firefly is also providing your lander for
And
your mission.
yeah, so this is super exciting for
very
me to see how
important
this
to
one
see how
goes.
this one goes, right?
Because it's the first one for Firefly. They're the ones that are going to be providing the landing for LunarVise, and it's like with the similar lander.
Guess what? We checked everything that was recording
Except that.
except for Jim.
Oh, no.
But you're recording his voice.
Yes.
But not his video.
That's correct.
Yay.
Oh, okay.
Yeah.
Well, that's fine.
That's all right. He hasn't said much yet anyway. So.
Yeah.
I
Hello,
sound better
Jim.
than I look.
Yeah.
Hey.
Yeah.
We
Yeah.
just realized we weren't recording your video until just now. But we weren't going to splice you in until later anyway, so that's
Yeah.
perfect.
fine.
And we
So-
aren't actually splicing you. Don't worry about your molecules.
Cool. Cool.
So that was the first one.
First launch followed by.
It's going well
It's
so
going
far.
well so far.
Okay.
Yeah, nothing's exploded on that one.
That's great
It's
news.
very good news. We're very excited. The next launch, which was maybe going to go before it, but then went after it, was the Blue Origin New Glenn rocket,
Yes.
which is very exciting for a different reason. It's the first time this rocket has launched. It's Blue Origin's bigger, heavier, liftier rocket. It's smaller than a Saturn V, bigger than a Falcon 9,
Yeah.
sort of comparable to a Falcon Heavy.
Yeah. It's got more payload
look up the
volume
thrust
than a Falcon Heavy,
comparison, and I
but
didn't see
less thrust at liftoff than a
So
Falcon
this is
Heavy.
Blue Origin's first orbital vehicle. So New Shepard that they've flown a lot now, and we've had payloads fly on, is a suborbital vehicle. So this is our first orbital vehicle.
And it's quite large
She was
physically.
so pretty.
It's you said smaller than a Saturn V, but not by a lot. I
Not
think
by
it's
a
only
lot?
about 10% shorter.
Shorter, but it's
Than a
narrower.
Saturn
'cause
V.
It doesn't have the like extra stuff.
Yeah,
The lower
but
end.
it's still a pretty.
But the fairing's pretty big.
It's a pretty big rocket, 7 meters in diameter, basically.
Yeah.
Um,
She's pretty.
yeah,
And it makes this beautiful flame because it's natural
liquefied
gas.
natural gas. Yeah, so a nice blue flame from Blue Origin,
Bright.
and it took off in the wee hours.
It did. There was a wayward boat, which we haven't had in a while, that
Oh,
delayed it from its
geez.
initial. It was supposed to go at 111, and everything was great, and then it's got delayed like
Range
half
safety.
an hour because there was a wayward boat
In the
in
Those-
the
those things happen.
range. Yeah.
And so in that one, they were at first flight, test flight. So primary goal was to get their little tiny payload, which is like the tiniest thing in their side, their giant payload fairing, which is just sort of like, let's make sure we can have communications with our payload to ground and all of that kind of stuff.
Yeah,
But-
they're calling it a Pathfinder for their Blue Ring, which is going to be an orbital space station concept. But
Right.
it was just like an element. It wasn't like a Blue
Right.
Ring.
Yeah, it stayed attached, I think, to the upper stage the whole time. And then they did attempt to recover their first stage back on a barge, following the same general principle that SpaceX has been doing successfully for some time now. We don't know. We haven't heard any details about what went wrong, but
Yeah.
during the burn, the reentry burn of the first phase, telemetry stopped. So you could see the numbers. The stage was slowing down. The altitude was going down. The rockets were firing. And then those numbers just froze.
Yeah, like it relit and it was
Oh,
coming back
no.
down, but it's not clear what happened.
Yeah. Then, less than 24 hours later, another giant rocket, even gianter,
Even Gianter from Texas launched Starship 7, Flight
integrated
Test
flight
7.
test 7. Yeah. And this one was notable because they were using it, and it turned out to be particularly notable for this reason. The upper stage, which is what has been
Starship.
called Starship.
I'm
now
so
they
confused now.
Now they like to call it Ship.
Yeah, I hate
Which
You're
I don't-
confused?
Yeah. Yeah,
Anyway,
watch out, Jim.
the upper
I don't know what's
stage.
happening.
The upper stage is the Flash Gordon thing that ultimately is going to, in principle, take NASA astronauts from the Lunar Gateway in orbit around the moon down
moon.
to the surface of the moon and then back up to the gateway so that they can get in Orion to come back to the Earth on the Orion capsule.
And in theory, someday it could do the
And
whole
it's-
thing by itself.
Yeah, right.
And it's
it-
called Ship now?
It's called. I'm going to call it Starship. I don't
I
care.
still call it Starship, but in their discussions, they refer to it as Ship. So it's like Ship 33 and Booster 17 or whatever.
Yeah.
So the big, massive thing with 33 Raptor engines is their
I think
super
this is like
heavy
an
lift
SLS
vehicle.
versus Orbiter kind of thing,
Yeah.
probably.
And so they were using a new version of the Starship that was
Yeah.
about 2 meters longer. They had a Pez dispenser on it to spit out.
Pez?
Yeah, you know what Pez are.
Yeah, yeah. Was it spitting out Pez?
It was spitting out space versions of Pez.
What was it spitting out?
Mock-ups of Starlink
I
satellites.
hate it so much.
Mock-ups.
Well, mass and volume models of Starlink satellites. So they weren't
But it
operational
was just
satellites.
plopping. It was just supposed to plop them into
It was
the
checking.
atmosphere.
Yeah, they were going to burn up with immediately on the first orbit. So they were. It was to test the deployment
Sure.
process for those things. So it was loaded up with those things, and then also, of course, they have the super strangely complicated return to launch site
Thing.
procedure for their
Gotta do a
booster.
pirouette.
It does a
flip.
little kind of do-si-do.
Yeah, it does a
kinda-
little flip.
It's like comes in. It's like I'm coming in this way. Then it's like no, I'm stopping. Then,
Now I'm
then
gonna
it-
flip
then
over.
it lands and it kind of does a little
Yeah.
dance like a weeble
Yeah.
at the end, and that part worked.
And it got caught by the chopsticks.
Yes, it came back to yeah.
That's
So
it.
all
So
that,
we switched to the booster.
yeah,
We switched to talking about the booster just then.
right,
And it did come back successfully
yeah,
and get caught by the chopsticks.
right. I was
Mechazilla.
all the strangely complicated stuff. I was actually talking about the booster,
I know.
but the upper stage also does strangely complicated.
Wait, so
stuff
what
too.
failed?
So
the upper
this is
stage.
the upper
The
stage.
upper
So if I
stage.
was gonna, I think we had this as a stumper recently. Like, which vehicle would you be on? And I think I picked
Yeah.
blue, but like,
Yeah,
they got their thing into orbit, and the booster landing failed. That's the failure mode I would prefer of the
Right.
two.
Yeah.
yeah, yes. So yeah, it broke up. There's
The Starship
broke. Yes,
did a little splody thing over Turks and Caicos.
yes.
Because there's lots of videos on the internet of a fireball coming in and then like little pretty fireballs going
Yeah.
down.
It's pretty spectacular firework display. Apparently, they had to redirect some air traffic.
Yeah, I
Commercial
think
air
that
traffic.
like I think they have that procedure in place just in case anyway. In
Right.
That, in
They
that
know the
track,
path.
They know
Right.
the path.
Yeah, yeah.
The FAA said they were assessing reports of debris on the ground,
Oh,
damage to property on the ground.
Really?
That bad.
Assessing
Turks and
reports in
Caicos?
Turks and Caicos.
interesting.
Yeah.
Okay. Oh, speaking of
Turks and Caicos.
things falling from the sky and landing on the ground.
Oh,
did you
that
see
meteorite.
Yes.
Yes. Have you seen
I
this
saw that.
video?
That was pretty cool.
Yes. A doorbell cam.
The doorbell cam catches a meteorite just going splat.
Yes.
It's just a little tiny rock. Somebody was saying that if you slow down the video, somebody had it where they slowed down the video and you could see the tiny thing at some point.
Oh.
And then there's just like a noise and it's just like this
Yeah.
particles on the ground.
It's believed to be the first video with audio of
Oh,
a
yeah.
meteorite hitting the Earth. It's caught by somebody's doorbell
Somebody's
cam
ring doorbell.
Amazing.
or
on their
something.
entranceway concrete path. So
Pretty
that's
awesome.
pretty cool.
We'll post it on Instagram.
Yeah. Let's see. Speaking of photos,
I think, and that concludes our launch coverage for the week.
that concludes our launch coverage.
Wow.
for
Been
the
a
week.
crazy
so much
week.
has happened.
It was
Yeah.
it was a good start to 2025.
Bepi Colombo.
Yeah, Bepi Colombo just did its sixth and final flyby of Mercury.
And now it's going away from Mercury.
And now it's going away from Mercury.
Oh,
and so the next
no.
time it gets to Mercury, it will orbit it.
Oh, okay.
Yay.
Yeah. But that's going to take about a year.
It's crazy
more.
how hard it is to get
Yeah.
into orbit around these inner planets.
We were talking about this with like things going close to the sun. Previous
Yeah.
episode. Yeah,
Yeah.
it's just hard to get in there.
It's super, super hard. But they tested their instruments and they took
Will it
some
be
more
in its
pictures.
hill sphere when it's orbiting?
It will.
It should be. Yeah, and everything seems to be working well. Their
Great.
instruments are working. The ESA, because Bepi Colombo is an ESA,
European Space Agency.
and JAXA, the Japanese Space Agency, combined mission, and they're kind of like two bits of a spacecraft just like smooshed together.
Yeah.
And so they're still smooshed. I think they'll become unsmooshed in a year.
Cool.
Yeah. So that was really that was successful and exciting, and they got some really cool pictures.
So it's, in a
and
sense,
stuff.
it's sort of like its last gravity assist from
Yeah.
Mercury itself to now put it on its
Basically.
final coast
Yeah, basically.
so the next big event is
fun.
Mercury orbit insertion, or as we say in France, moi. So, well, staying in the inner solar system.
None of us should have laughed at that.
Sorry.
It was very clever.
Staying in the inner solar system.
I like to do that.
Our first science topic is kind of a short one, but sort of interesting, partly because the publication from the American Geophysical Union that wrote a story about it had a hilarious typo, referring to something as an asteroid. Asteroid.
Troid.
Or let's say it again. Ready? 1, 2, 3.
Asteroid.
So yes,
It was a typo.
We're 5.
And also, we're 5 years old.
So what the actual science story is about is a spike in the abundance of impact craters on the Earth about 450 to 490 million years ago in a period called the Ordovician.
Ordovician.
Yeah, Ordovician. That's
Period.
definitely
Is it a period?
Oh, I don't remember.
I don't remember.
It's a thing.
It is a thing.
It's a time range in the Earth's geological history.
It is a period.
And there's a greater number
period.
of significant impact craters that date to that time. And so the researchers in Australia backtracked plate tectonics to that time to say, where were these craters on the Earth when the things hit? And they
Pangea.
found that they were all within about 30 degrees of the equator.
Oh.
So that's sort of the big clue. So first we have to rely on the relative accuracy of the date of the craters, which is a tricky thing to do.
Yeah, with all
Right.
the weathering that happens on Earth,
Well,
it can be
right.
pretty hard.
Well, also geological processes can reset the apparent age.
Yep.
If you're doing radioactive dating, things can heat up, and then it's like it resets the clock on those things. But with all of those caveats, if we take those ages at face value, they're all within about a 40 million year period or so, and the craters are all pretty close to the equator. We're talking about 21 good-sized craters here.
Okay.
So if
21,
you
that's
throw-
a lot.
a lot.
For Earth, that's a lot
Yeah.
of craters.
So if you throw 21 big things at the Earth from the solar system, they are not going to hit within 30 degrees of the equator. It's statistically highly unlikely.
Okay.
They're going to hit all over the place because the Earth's size is tiny, tiny, tiny compared to the sort of thickness of the region where things orbit.
Sure.
Okay,
Makes
even though
sense.
it's like everything's in a plane, why wouldn't the things orbiting the sun hit on the Earth's equator? No. The Earth is like a little tiny speck in a much thicker disk of the solar system. So you'd expect these impacts to be all over the place. Oh, they're near the equator. How do you do that? Put a ring around the Earth.
Got to put a ring on it.
Right.
Mm-hmm.
Mind meld.
Yeah. Oh, yeah.
We're so good at it now.
yeah, we should do that again after this episode. So how do you get a ring around the Earth? Well, it's the same stupid problem
Ask-
I'm always talking about every
Ask
other
you to- ask you
episode
to marry you.
with with Saturn. How do we get the rings around Saturn? You put something that's not a ring around. You put something that's not a ring in orbit around it, and then you break it up.
Is it
one
in
way
the
or
hill
another.
sphere?
It would have to be in the hill sphere. So the most likely scenario would be an asteroid,
Sure.
not an asteroid.
Oh.
An asteroid gets tidally disrupted and captured into orbit around the Earth, something like 490 million years ago or so, and the debris makes a ring. And for all the processes that we've talked about ad nauseum about Saturn's rings, those orbits decay over time, and the stuff ends up spiraling in and hitting the Earth, making a bunch of impact craters on the ring. And just for context, there's evidence that this kind of thing may have happened, interestingly, around moons of Saturn. Like that some of the moons of Saturn themselves may have had little mini moons orbiting them that ended up crashing into those moons, making, because we see this enhancement of craters in the equatorial region of some of those
Okay.
moons. So it's not, it's not an unprecedented suggestion.
It's fun.
That is really fun.
Yeah.
Where-
So we may have had a short-lived
Are they
ring.
all Australian craters now?
No, I don't actually know where they
Where-
are.
It would
Are
have
all
to
of them
be.
now?
I mean, it would have to be in some
Disparate locations.
but like somewhere where there
So-
not a lot of like
Yeah.
stuff that would overprint it. So
Right.
Australia would be a good spot because
Yes.
it's very, very old crust. Canada,
Right. And this
Southern
brings
Africa.
up a really important point, though, that I forgot to mention, which is that you could say, oh, well, maybe there wasn't things to record a crater farther away from the equator, but there were. So they backtrack everything. There was plenty of if a crater hit up here, we would have seen it.
Right.
We would see it.
Still see it.
Yeah.
Yeah. And so there is a strong statistical case to be made that there was something circumterrestrial rather than circumsolar.
How does that get affected by the moon?
That's an interesting question.
It's like an interesting in-body problem.
Yeah. The moon at that time, I don't know the details, but yeah, it would have been
It would have been affected.
perturbed.
Yeah.
Yeah.
Cool.
So that will provide a nice transition to our trivia, which is all related to all this sort of hill sphere, Roche zone business.
Oh, good.
That's Audrey's favorite type of trivia.
That's my favorite type of
Sometimes
sphere.
we do rocket launches for Jim, and sometimes we do gravitational dynamics for Audrey.
Yay.
Love it.
So, I started off. I want to provide you with a hilarious hallucination by artificial intelligence.
I can't wait.
Yeah, I think you're pulling my leg here.
No,
But,
I'm actually excited for this.
I asked artificial intelligence, how big is the sun's hill sphere? And it told me the sun's hill sphere, which is the region where its gravitational pull dominates over other celestial bodies, extends to a radius of roughly 1.5 million kilometers, roughly equivalent to the distance between the Earth and the Moon, meaning Earth's hill sphere is entirely within the sun's hill sphere. Key points about the sun's hill sphere. This is all I'm quoting AI. Radius approximately 1.5 million kilometers. For context, that's 1% of the distance from the sun to the Earth. Okay. Comparison, Earth's hill sphere within the sun's hill sphere has a radius of around 1.5 million kilometers.
Oh.
So there's an interesting comparison. Yeah.
Oh, good.
So why did AI hallucinate on this question?
Is it a hallucination though?
Well,
Is that the
whatever.
trivia
That's
question?
No, it isn't. But it's an interest. It had a reason to hallucinate because it was an ill-posed question,
Okay.
and the reason is the hill sphere is always relative to something else. Like, what's the thing that you're competing with gravitationally? So the moon is within the Earth's hill sphere, where the sun is who we're competing with. So
Right.
the moon is held to the Earth, not to the sun, right? So it has to have that other thing there. If you just say, "Where's the sun's hill? What's the sun's hill sphere?" It's like, well, what else is there, right? It's if there's
Okay.
nothing else in the universe except the sun's hill sphere is the size of the universe.
Right. Okay.
So here's your actual question. What is the sun's hill sphere size competing with the galaxy if you treat the galaxy as a point at the center of the galaxy? Follow-up questions will be, which planet has the largest hill sphere, and which has a larger hill sphere, the Earth or Pluto? So we'll come back to that
Good
after our
questions.
astrophysical stuff. Thank you, Jim.
That's good.
All right. I'm actually pleased that I
Yeah.
got
I
Jim
like it.
interested
I like it.
in the trivia.
Yay.
All right. So, Jim, you have the floor.
Oh, shucks. So just this past week, I'm just so excited to get the floor. Just last week there was a big meeting. Did any of you guys go to the American Astronomical Society meeting?
Astronomical Society meeting?
No.
No.
Where was it?
I don't know.
I go
didn't
to
go.
the American Astronomical Society's Division for Planetary Sciences meetings.
That's the one we go
Right.
to.
There were several.
Right.
There were several folks who went to the AAS meeting this year, but
Yeah.
I was not one of them.
Neither was I.
Yeah, I wasn't either. We had several of a bunch of our students go, and they missed the first week of class, which was fine.
Boo. So did
That's
ours.
a good reason to miss class
Yeah.
is to go to a big AAS meeting. But anyway, course, these big meetings are places where lots of fun things get announced.
Yeah.
One of the things that got announced is a cool look by JWST at, I don't know, we've talked a few times about how cosmology got broken by JWST, but when they saw a bunch of big galaxies in the early universe, big meaning they were bright, and so if we assume that light is coming from stars, then we can calculate what their mass is, and they're like too many stars, they're too big to form that early in the universe. And we talked about whether that should break cosmology or break astronomy or not. I said, it's probably just something to do with us not understanding the galaxy formation process very well in the early universe. But looking at more and more of these things, and they call them little red dots, right? These bright early universe galaxies, we've determined that almost certainly the explanation for it is not that they have that many stars, but that they're bright because of black holes that they have, and the black holes are spewing out a huge amount of energy. And unlike galaxies in the nearby universe, in the early universe, those black holes would be shrouded in a lot of gas and dust. And so all that energy from the black holes gets absorbed by all that gas and dust, and then that gas and dust glows.
Oh, and it looks more like a star.
And it looks more like starlight
Oh.
than a bunch of like
Than a
X-rays
typical,
and stuff like that. Right.
Because typically black hole radiation that's coming from the accretion disk around a black hole is going to be obviously that because of the spectrum. You're going to be looking at high energy radiation.
It's going to have a lot of high energy stuff, gamma and X-rays. And
in fact,
has almost none of that.
That's the original way we basically thought we saw black holes, was because we saw such incredibly energetic radiation coming from a very concentrated point. We're like, okay, this is probably one of those things Einstein was talking about.
That guy.
That's right.
Something.
That's right.
Something very.
He's always talking about something.
Yes.
That's right.
And
a
How
lot
many,
of
things, how many things do you think he came up with that like just didn't make it into the record, that were just like totally out there, that like weren't real?
Like none. The
Really?
dude with the chainiest. Yeah.
Everything he wrote down was like, no,
was correct.
No, I mean, not entirely. Remember, he was kind of anti, even though he was one of the kind of fathers of quantum physics, he kind of was against. He didn't believe in it for a while.
Yeah.
Really?
Yeah.
Oh.
He was like, I got these ideas and I hate that they're right.
Yeah.
Oh. Wait, I have a question. Jim, is it easier
That's
to
not allowed
make...
on this podcast.
Never mind. Is it easier to make a black hole than it is to make a star? Why does it make sense that there's black holes in the galaxy and it doesn't make sense that there's a lot of stars?
I like
Right,
that
it is
question.
easy. When you're first building a galaxy, you get a lot of stuff falls to the center. So these black holes that we're talking about are not stellar mass black holes. They're these supermassive black holes at the center. And those can form fairly early because a huge amount of mass falls into the deepest part of the gravitational well, and you get this black hole that forms, the huge black hole that forms very early before you have the time to make a lot of stars. And then that black hole eats a lot of the gas and dust and a few of the young stars from the center of that galaxy, and it produces a huge amount of energy. Now, I mean, we see those kind of active galaxies in the more recent universe as well, but they're not shrouded in all that gas and dust, because all the gas and dust has been made into stars and already, cleared out, basically. And so we see in the more recent universe, those things have lots of energy in X-ray and stuff like that, but these don't.
Because we can actually see through to the very hot disk around the black hole itself.
Exactly.
These early galaxies, we can't. And then sort of somewhat coincidentally, all that stuff around it is heated up to sort of stellar temperatures.
Right.
And so then it's looking like stellar spectra.
Right. In a sense. I mean, if you look carefully, it's not exactly stellar spectra.
Well,
but
presumably that's how they figured out that's what's going on here.
Right. Well, I think they can even see, even though you can't see to the accretion disk, the hot part of the accretion disk, you can see some rotation there. So they use Doppler shifts to see there's a big swirling stuff in this kind of center of these things. And that's how they're doing this differentiation.
That's really incredible that, what are we talking about? 10 billion light years, 11 billion light years away, we're able to measure, to resolve to measure the rotation taking place in the core of a galaxy.
It is
at that
remarkable.
Distance.
It is remarkable. But we're
very
amazingly
annoying
good
to me.
at
I mean, that's just
measuring
so
Doppler
crazy.
shifts. Yeah.
How many pixels does it cover? Like how much of the galaxy is rotating in one direction versus the other direction? Are they like working with like 1 pix or like 2 pixels?
Probably. I don't know.
Wow.
That's a good question. I don't.
That's
I'm not an
amazing.
observationalist. Right? They're digging
Yeah, I mean,
data out of
well, I
mean,
can say I don't know the answer for sure to this question, but one of the way you can see Doppler shifting is just line broadening, right? If you're
Right,
looking at it,
right.
if you're looking at an emission
Oh,
line,
right.
That's right.
some of that light is coming from something that's moving towards you, so it's at a bluer wavelength, and some of it's coming from a source that's moving away from you, so it's at a
makes
redder
sense.
wavelength. So the emission line gets broader, and you can
That's right.
model
That's
the
right.
shape of that broadening. So you don't even need any
You don't even need any
pixels.
resolution. Right. It
Wow.
doesn't need
Right.
to be
You
resolved
just
at
need
all.
a good
Right.
spectrum and then physics. I tell you, the amount of information light gives us
It
just
is
blows me away
preposterous. It's preposterous.
because it's such
Good
a
job,
sort of a
light.
simple thing.
Or
It's-
is it? It's so complicated. Is it particles or is it waves?
It's- I don't fully understand it, but it's like, it doesn't take very many numbers to define a thing of light. Right?
Right.
So-
So the grand finale of all this, by the way, is that cosmology is not broken. That's a really nice
Yay.
explanation. It's a nice explanation for why we're seeing apparently really big galaxies when they're not actually that big, which
Okay.
makes it nice and makes them fit back into our nice, cozy cosmology.
Right.
Not broken.
And your answer to Audrey's question, just to emphasize, is that yes, it is easier to make a supermassive black hole, or at least you make that
You
faster
make that sooner, right?
Yeah.
than you make a bunch of
That makes
stars in a
sense.
disk in a galaxy.
Early universe was pretty crazy.
It
I'm
was.
glad I wasn't around back then.
Same.
Yeah.
Yeah.
I wonder if someday people will be looking back at this time and go, man, things were crazy back in the
Probably.
13.8 billion years after the Big Bang. They had galaxies all over the place. The observable
I
universe
mean, I
was
hope so.
filled with stuff, and now it's just sad and empty.
No.
Yeah.
Oh.
Boom.
Well, speaking of old distant stuff in JWST, there was another little story about an old supernova. This is just a little side note. They saw a supernova about 10 billion light years away, so universe age of a couple billion years or something like that, maybe 12. In any event, and it's more energetic than comparable supernovas that we see locally. So in galaxies that are relatively nearby. And they think it's because perhaps this is so old. Remember, the astronomers had this stupid numbering scheme for populations of stars. The first population of stars is population 3, followed by population 2, followed by population 1. Astronomers apparently are super stubborn because they start lettering
Yeah.
things or numbering things before they know what it is, and then after they figure out what it is, they're like, "Oh, gee, it would have made more sense if we'd numbered that the other way around." But they don't change it. Then they're just
that's
like,
so
I guess there's nothing we can do. We can't do anything about it. So,
What it is.
so the old original stars,
We'll redefine planets, but not that.
right, right. Well, planetary scientists are more, follow the
We're
information.
hip. We're with it.
We're just better people.
Those
That was a really bad definition.
those early stars, there's basically just hydrogen and helium. So they didn't have any of the other stuff mixed in that
Losers.
astronomers, again, teasing astronomers, call metals. So they're low metallicity stars. And so that may be related to why this particular supernova, which was probably an explosion of something like 20 times the mass of the sun, blew up. It was a pop 3. The ones that we see nearby of those kinds of masses are like pop 2 or pop 1 stars. So they've got other stuff mixed in. And for reasons we don't yet understand, they're less energetic than that earlier one. So they're expecting that between JWST has seen like 80 of these ancient supernova. Yeah, type 2 supernovas so far. And the Nancy Grace Roman Space Telescope that's coming up is predicted to see thousands
Ooh.
of these ancient.
Oh.
Very nice.
So we'll really
You'll learn a
piece
lot.
together about a lot about how stars work and how they blow
wow.
up, and things that go blow up are fun.
Yeah.
Good job,
I
J-Dub.
agree.
Yeah.
And more.
All right. Are you guys ready to take a crack at the Hill Sphere trivia?
No.
I mean,
I'll take that as a
yeah.
yes.
Great.
So we'll start with, suppose that you replace the Milky Way galaxy with just a thing at the center, and the sun is
Sure.
orbiting that.
I'm so bad at this. Okay.
How big would the sun's gravitational sphere of influence be? Jim, do you want to answer
say
first?
That again?
Imagine that instead of the Milky Way being all distributed mass
Sure.
all over the place, you just ball it all up
Yep.
and put it as a thing at the center, and the sun is orbiting that thing.
Great.
Then how
Is the
far
sun?
out does
This
the
is a paradox because the sun is in the Milky Way, so it's also in the center.
Okay, but it's only one trillionth
Got it.
of what's in the center.
It's the
So
most important thing to me.
yeah. So
Uh,
how far out does the sun's gravitational sphere of influence go?
I'm going to say 100 light years.
100 light years, says Jim Cooney.
I'm
Top quark. So what that would say is you take a planet orbiting, there's like the Milky Way is now reduced to
just-
two things, a giant thing in the middle and the sun. And if you put a
Two-body
planet
problem.
around the
Great.
sun,
3-body
it would
problem.
stay orbiting the sun out to what distance?
Yeah.
And Jim says out to 100 light years.
1 light year.
Audrey says 1 light year.
1 AU.
Addie says 1 AU. Audrey,
Really?
yes.
Yay!
It's about 2. And, I'm,
2 light
just
years?
put it, 2 light years.
Whoa.
Yeah.
Nice.
Yeah. So, and that's one way you could define sort of the size of the solar system. We've talked about like
I see.
Voyagers or pioneers leaving the solar system based on like where the sun's plasma.
I like that definition of the solar system.
I do too.
I like it.
Yeah.
Yeah.
I like it.
And so by that definition, those spacecraft have not left the solar system yet.
Yeah. I mean, like, is it a gravitational definition of
It's
the
a
solar
gravitational
system?
definition.
I like a
Yeah.
gravitational definition.
Yeah.
I feel like
Yeah.
there's
Yeah.
It's a
For this
And-
kind of thing.
And the
Maybe
Oort,
not
yeah.
for planets.
no, not for planets.
yeah, and the Oort cloud does extend out like
Yeah.
there are comets in the Oort cloud, part of our solar system, I think go out to like about 1 light year from the sun, which is
I
kind
always
of
forget how
crazy.
big the Oort cloud
Yeah, me
is.
too.
It's crazy big
We rarely depict it in depictions of the
Right.
solar system.
and,
We don't
Because
and,
it's like
and rarely accurately.
years up the
Which
scale.
which planet has the largest hill sphere? And now, of course, the planet is we're within the solar system. So it's like, how far out can you go and be orbiting the planet before the sun takes over and says, no, now you're orbiting me, right? So which planet, I have to say how big, which planet has the largest hill sphere?
I feel like it's a gotcha. But
do
I'm
too.
gonna get got. I'm gonna say Jupiter.
Neptune.
Audrey says Jupiter.
Jupiter.
He
Jim
said
says Neptune.
Saturn.
It is Neptune.
Yeah,
And-
I thought
okay.
it might be.
Why, Jim?
Because it's so
It's
far
far
away from
out.
the sun.
It's- yeah.
yeah.
So the farther you get
I
from the
wanted to
sun,
say
the
Neptune,
less the sun is caring about things.
Let
So
Jim
along
have
those
it.
same lines, which has a larger hill sphere, the Earth or adorable little Pluto?
Pluto.
Larger
Yeah, I
hill
bet it's
sphere.
Pluto.
It is Pluto. Its hill sphere is 4 times bigger than the Earth's hill sphere.
That
Really?
jerk.
Because even though it's so much less massive than the Earth, it's so far out there that the sun is a pretty weak influencer. So
for Pluto.
It's one of the reasons perhaps with what the giant planets are able to hold on to these very distant captured objects in orbit around their around themselves in their giant hill spheres. Right?
Yeah.
Cool.
Crazy.
While it may have
Awesome.
felt like traveling to another planet in a broken suspended animation chamber, it was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners right here in Central Florida. I'm Addie Dove.
I'm Jim Cooney.
I'm Audrey Martin.
And I'm Josh Caldwell. We're the Astroforks, signing off until the next episode of Walkabout the Galaxy.